All right.
At least.
Do I need to remind you what the mean value theorem is first before we do Rolle's?
Sure, yeah.
Okay. Mean value. Wait, does anybody need a packet? I can't remember. Did we do that Friday? Yeah. You got it. Okay. Mean value theorem. If you have two random points that can be wherever you want, as long as it's continuous and differentiable, which just means it's a normal smooth curve, the average slope between these endpoints is going to have the exact same instant slope at least one time. So like however this thing curves, you're going to have the same instant slope at least once. Could have it more times. So Rolle's theorem, I'm not entirely sure why they decided to make this a separate theorem. I've never understood why they made it its own theorem. So mean value theorem is that two endpoints can be wherever, right? And then you take the slope between these two endpoints. Rolle's theorem is the exact same thing, but it only applies to one situation, and that's where the two endpoints are level. And so you take the slope between these two endpoints, which would be 0, and then Rolle's theorem says if your two endpoints have a slope of 0, then you're guaranteed that one time in the middle will have a slope of 0. I shouldn't see guaranteed one time. I should see you're guaranteed at least one time will have a slope of 0 in the middle. And it still has to be continuous differentiable. This Rolle's theorem is essentially one specific case of the mean value theorem. It's the exact same thing as the mean value theorem, except it's only the one case where they're level. So that's why I've always wondered why they consider this separate. But they do, so we learn it. And so, like say with mean value theorem, the only thing we're really checked for is continuous differentiable. For Rolle's theorem, they theoretically check for a third criteria, which is that the two endpoints have to have the same height. So somewhere here it is f of a equals f of b means they have the same height. So if that happens, you're guaranteed a slope of 0 between them. So they don't really mention slope anyway, other than right there. But Rolle's theorem and mean value theorem are the same idea. Rolle's theorem only works when they are level. Mean value theorem is for any heights. So here, I thought we would just kind of go to a problem rather than finishing that graph on the other page. There's nothing wrong with that graph, I don't know, I thought it was kind of lame, so I wanted to move on. So we're given a quadratic function, x squared plus 2x minus 3. It says find the number c that satisfies the conclusion of Rolle's theorem. Okay. First thing we need, whether it's mean value theorem or Rolle's theorem, is it has to be continuous and differentiable. Now it's how should I say it? Continuous means that there's no values of x that would be undefined. So if you're looking at the equation, is there any number you can't put in place of x? And for this one, definitely not. If it was a divided by x. Generally, like vertical asymptotes or wholes are the only thing that create undefineds. So you have to have a division of a variable in some way to get there. So this is just a polynomial. So f of x is where we look for continuous. So that's the first thing I checked for. And this one, we can use any number in place of x, so it is continuous. There is no like proof or anything you like have to write down for that. Mhm. To check for differentiability, you look at the derivative. The derivative is all the different slopes. Differentiability means that you have a slope answer. So if there's any numbers in the derivative that would be undefined, that's for differentiability. Our derivative has no locations that we couldn't put an x in place of. And so since this is a polynomial, it's guaranteed to be differentiable as well. So these are the first things we have to check for. Doesn't matter if it's mean value or Rolls. And it feels kind of weird because you don't have to prove something is continuous or differentiable. You look for spots where it wouldn't be continuous or wouldn't be differentiable. And then if there's a location that's not continuous or differentiable, you check to see if it's in your interval. Because we actually don't care about anything outside the interval. Now this one says Rolle's theorem. So Rolle's theorem says that f of a has to equal f of b. So I'm going to check that f of -3 is equal to f of 1. If this was mean value theorem, we would have gone directly into the problem. But Rolle's theorem says check that they're level. So f of -3, 9 minus 6 minus 3 is 0. F of 1 is 1 plus 2 minus 3, which is also 0. So f of -3 is equal to f of 1.
Wait, are we checking their derivatives to see if the derivatives are equal?
No.
It's just the normal equation?
So Rolle's theorem, we're trying to see if the heights of the original points are the same, because then the slope between them is 0.
Okay, so it doesn't matter if both of their slopes are 0, it's just
Correct.
the heights? Okay.
So the next thing we do is, because we met all these conditions, we're guaranteed that at least once between -3 and 1, there is going to be a slope of 0. Now this one, since we have equations, we can actually figure it out. And so we're trying to find the number c that has a slope of 0. So the way they write that out is they're trying to find f prime of c that has a slope of 0. And the only reason I'm writing this is so that we remember to use c, not x. I don't know why they're very particular about it on the AP test, but we have been told that they are. So I'm going to write the derivative, but I'm going to use a c instead of an x. So I would say 2c plus 2 is equal to 0. And then you solve it like you normally would, but instead of x, it says c equals. So that's the location. And that is between -3 and 1, so that just basically verifies and proves that it's true.
X equals 1.
At x equals -1,
Oh, yeah, that's
it has a slope of 0. But they would like us to find the c value that makes the theorem true, so we write it as a c instead of an x. Just go with it. Basically, you're writing a c instead of an x. I don't know. Anything about this one you want me to explain? It partially just feels weird because we don't really do much. It told us from the start. I believe on the AP test they will also mention Rolle's theorem, so it's not like something you'll necessarily have to just come up with on your own. But who knows, maybe they won't. Okay, do we want to do the sports car one?
Sure.
No.
Doesn't matter to me. There's like 4 or 5 examples, and I know we don't have time to do them all, so. Okay, sports car speedometer registers 50 miles per hour as it passes a patrol car at a mileage marker. 4 minutes later, the car passes another patrolman at a marker that is 5 miles from the first. The driver notes, why would the driver know? The driver notes that the speedometer registers 55 miles per hour. Can the highway patrol use the mean value theorem to prove that the driver was exceeding the speed limit of 70 at some point between the two mileage markers? Now, I would question why he's going 50 and 55 if the speed limit's 70, but this one feels a little bit more difficult. I shouldn't say feels difficult. It's sort of disguised. So, the miles per hour is the derivative. So, mean value theorem is that we're trying to find the average slope. And then if we find the average slope, we're guaranteed that the instant happens at some point between. These are slope answers already. So if we were going to use the mean value theorem on this problem, we actually wouldn't set this up with miles per hour. Miles per hour is going to be the answer we find. So I'm going to set this up as, like, say, the first marker was time 0, mileage 0. So, like, we'll do a distance and time, like a position function. We don't need to know the function at all, but we'll do it with position and time because then the slope is velocity or speed, right? So here's the first checkpoint. The second checkpoint, what did they say for time? Didn't they say like 4 minutes? 4 minutes later, which is annoying because it gives us minutes, but still. And the slope is per hour. So we'd have to change minutes into hours, which I believe that's 15th. So that's time equals 1/15 hours. And then the distance, it said 5 miles, I believe, yeah. So the distance is 5 miles later. Now we know this is continuous and differentiable, even though it doesn't say it. How should I phrase this? Basically, if you're driving a car, right, like your speed can go up and down, but you're still driving. So the fact that you're driving means it's continuous and differentiable. Like, your speed may change, that's the differentiability part, but there isn't a location that you're all of a sudden not driving or not having a slope. So it's continuous differentiable even though they don't bring it up or register it. So we need to find the average slope between those 2 points. And that's the f of b minus f of a. It just feels strange to write this one as a formula because you guys in your head kind of registered driving already. We're trying to check if there is a c value that has the same instant slope as the average slope. So f of b would be 5. Um, 75? So basically, if this car made it 5 miles in 4 minutes, they're averaging 75 miles an hour. So if they're averaging 75 miles an hour, then you're guaranteed at one point, they were definitely doing faster than 75 miles an hour. This had to have been their curve somewhat, their speed essentially, right? Like, they were definitely, if you average 75, and they were going 50 and 55 at the beginning and end, then they were probably doing about 90 in between. So the mean value theorem just proves
Still slow.
that they had an average slope, or an average, mean value theorem proves that they had an instant speed of 75 at one location between the two points. And no, the highway patrol would never do that. I'm assuming you guys, practical math, you guys already know that, you guys should already know that 60 miles an hour is a mile a minute, right?
Yeah.
Okay, I'm assuming they still teach that part, right? So that's one way you just kind of register how long it's gonna take for you to drive something. So this one, when I read that they went 5 miles, but it took less than 5 minutes, instantly in your head, you should know that they were going faster than 60. Nothing to do with the problem, but still. I figured I would check to see if they still taught that. Do you want to do this one?
No.
No? Just because it was graph? I see, well, okay. Okay, now we're on the calculator problems. You guys can blame Olivia.
I would like to do graph work.
Oh, well, you wanna go back?
Yeah.
Oh, dear. What time did we get done? 27? Oh, so we should have time to do all of them. I was basically going to try to go through examples with you guys and then let you work for whatever time we had left. So that's partially why I'm asking if you want to do examples or not. All right, doesn't matter to me. There's so many people on there. Is there like something to do today or what? Multitasking only works so well.
It does work.
No, it works, just not very good. Multitasking means every task that you're doing is gonna be subpar.
Well, I just needed to make sure my decision wasn't posted,
Is that gonna,
and it wasn't.
but that's not gonna have any effect at all.
I will on my well-being. Does that not matter to you?
For the most part, it is. One could argue that it shouldn't affect your well-being, but I get that. Okay, we have 5 minus 4 over x. Find all values of c in the open interval 1 to 4 guaranteed by the mean value theorem. We should call in people.
Roll.
Why did she?
Oh, right.
to roll?
Because she asked for it.
You want
I wasn't even gonna roll, but she asked for it.
You can roll today.
Did you wanna roll?
Yeah, well.
Oh, okay. I think Sebastian was angry that he got called on before the dice hit last night. I would expect to be rolled.
Rabat.
What's the first thing we check for mean value theorem?
The points.
That's Rolle's theorem. Or, unless I misunderstood what you meant by the points.
Or the y value.
That's Rolle's theorem. So Rolle's theorem, the two y values have to be even. But mean value theorem and Rolle's theorem, they're not the first things you check for anyway.
I don't know to.
She's trying to help you out.
If it's continuous.
Okay.
differential.
Continuous and differentiable. So I'm gonna check for continuity first. I'll check for differentiability next. FYI, if either one of these two things fails, then we won't even use Rolle's theorem. Now this one kind of implies that it's going to work because it tells us to do it. But we still have to check for it. Continuous. Right, Beth? Do you want to keep going?
Yeah.
Okay, How do we check if something is continuous? What do we look for?
Left-hand limit equals right-hand limit.
Maybe?
No breaks in the graph.
Okay. How do I do that from an equation? We don't have a graph. Oh, pretend we don't have a graph.
If we substitute an x value, we should get like a.
Good. So this one does have x values you can't use. You can't use x equals 0. Is that going, let's call on somebody else. But good.
Daniel.
Daniel, we can't use x equals 0. Is that going to affect our problem at all?
No.
Where does our problem focus? Like it tells us where to look.
Oh, 1 to 4.
1 to 4. Since x equals 0 is outside of 1 to 4, then that's acceptable and okay with us. Our graph is continuous from 1 to 4. Okay? Differentiable. Oh yeah, sorry, I was gonna have Daniel call, but I forgot, we've got to roll it.
Matthew.
Matthew?
Yeah.
How do I check for differentiability?
Take the derivative of the function.
All right, sounds good. Negative 4x to the negative 1. So that would be positive 4x to the negative 2. Okay, so there's our derivative. Do you guys need me to go through how to get the derivative? Oh, come on. Derivative of 5 is 0, so I ignored that. This is the same thing as negative 4x to the negative 1 power. So power rule, multiply the negative 1 and the negative 4, and then subtract 1 on the power. So I would get positive 4x to the negative 2. I'm writing it like that because that's easier in terms of finding answers. Okay, so Matthew, do I have any values that are not differentiable?
No.
Wait,
0.
2 values or at x equals 2?
Neither.
Neither, okay.
Okay. I guess 0, but none between 1 and 4.
Perfect. X equals 0, there is no slope answer. So, but that's okay because we only care from 1 to 4. So it is continuous and differentiable. For mean value theorem, those are the only 2 things we check. So at this stage, now we immediately go to the mean value theorem formula, which is the average slope is equal to the instant slope, and we're looking for that location. Sebastian, whenever you get a chance, you can roll another person.
Spencer.
Huh, that one seems to be, his name came up before it even landed.
No, it landed.
1 is the answer, because it's y value 4 minus y value 1 over x value 4.
Oh, you're gonna have to back up for me though. It sounds to me like you already finished it.
Yeah.
How did you fill that out? That's what I was hoping you could tell me to do. Because I think some people in here need you to fill this out for them, so.
So the y value of b is 4.
Okay, so f of 4, which is 4,
Yeah.
yeah.
Minus 1, because
F of 1 is, it's actually kind of weird, but okay.
yeah. Same with the bottom, actually.
Yep.
It's 4 minus 1.
What do I write on the right-hand side, the important one that I wanted to make sure was correct?
3 over 3, and then you get, which is the slope of 1.
No, but over here.
Oh, f prime of c.
No. F prime of c is, so it's the derivative, but writing a c instead of an x. Yeah. Yeah, I mean, you were correct, the left-hand side is equal to 1. And then I'm just going to solve this equation, which would make c squared equals to 4. And then c can be plus or minus 2. Wait, didn't you tell me it was 1? Or were we talking about the slope the whole
I was talking
time?
about the slope.
Oh,
Why the c squared at the bottom? Why did we just do 3/3?
say it again? The left-hand side was 3/3. I just wrote 1. Our goal is to figure out where the instant slope is equal to the average slope. The instant slope is the derivative equation. The average slope was what we kind of calculated. So for us to figure out when it's equal, we set the equation equal to the number. One more person. Oh, go ahead now.
Is the slope -4?
Nope.
I mean, the derivative question, right? Or the derivative?
The derivative equation was positive 4 over x squared.
Oh, it landed on.
It landed on Donald.
Oh, let's go.
Donald, why is this wrong?
Because it doesn't, it's just plus 2, I mean,
He wants you to finish thinking first.
it's not, the minus 2 is not within 1.
Good. So the instant slope is equal to the average slope at positive and negative 2 across the whole entire thing. But we actually only cared from 1 to 4. So the only answer from 1 to 4 is positive 2. Good. I'm kind of torn here because do you guys want me to do a calculator one with you? Do you feel pretty bad about your calculator skills at this point, I take it?
Yeah.
Oh dear, all right. We'll do a calculator one together. Let's do the trig one, since you guys hate trig too.
Where is it?
Example 6. Determine whether that satisfies the hypotheses of the mean value theorem on the interval. Isn't hypotheses more than one hypothesis?
Yeah.
Shouldn't that be a hypothesis then? Look at me flexing my math grammar. What was the sine of 2x? No, sine of 2x minus
Plus 2x.
sine of 2x plus 2x. Okay, sine of 2x plus 2x. I am also going to graph the derivative immediately as well because I don't want to take the time to do that later. I can either find the derivative myself or tell the calculator to find the derivative. Both are correct. Do you remember how to tell the calculator to find the derivative?
Nope.
Yes.
Okay. If you do not, it is under math. Actually, there's multiple places, but n derive number 8 is the derivative, which technically means only at a single number, but we just tell it to do it for every number. So we would say d dx. You can retype sine of 2x plus 2x if you want. Otherwise, you can just tell it y1. y1 is a variable. You don't have to do this, I'm just showing you where it is. You could literally just retype the equation. It's a function variable. So they're very annoying to get to be honest. So you can either tell it y1, or you could have just typed sine of 2x plus 2x again. Whichever is quicker for you. And then we say at every x value. And then this is where it'll go super slow. So if you knew how to find the derivative and you did it on your own, it would graph at normal speed. I already forgot the x values that it wanted it. Oh wow, that went faster than I thought. 0 to pi, okay. So I'm gonna change my window, and I am only gonna look from 0 to pi, because that's the only thing I actually care about. So my x min will be 0, my y min will be pi, x max will be pi. Okay, regraph. And I know yours is just gonna like putter along. It's really nice. Okay, looking at this one, does mean value theorem work on this problem? What would we look for? Well, what would it look like if it didn't work for mean value theorem?
There would be X values missing.
Yeah, there would be a section missing or an asymptote or something like that. Continuous, I believe the red one was the original function. So the red one is the original function. It obviously is drawn everywhere, so that's continuous. Differentiable, I could look at the derivative for differentiable.
I think it's the blue function.
Backwards?
It's the blue function.
All right. Actually, I could have just done that. If you're not sure, you can hit trace, and then it'll tell you which one you're looking at. So yeah, okay, blue function. It's drawn everywhere, so that's continuous. And my derivative, the red one, is also drawn everywhere, so it's differentiable everywhere. If there were missing parts, then it's not continuous, not differentiable. All right, so now I need to know what I'm trying to figure out. Determine whether that satisfies yes, continuous and differentiable. Come on. G of x is continuous. Good. G prime of x is differentiable. I wonder if you should say G of x is differentiable. Should look that up.
If it's G prime of x, isn't that assuming it's already differentiable?
No, because you can find a derivative, because the derivative is for every x value, but there might be individual ones where there's not an answer. Okay, so we did that part from 0 to pi. If so, find all numbers C such that, why did they write it that way? Instead of divided by b minus a, they multiplied it over there. That's interesting. So we need to figure out what is g of pi minus g of 0 over pi minus 0. And we need to know when the derivative is equal to that. Okay, so let's go back to the calculator and find g of pi. If I'm on the trace feature, I can find the answer for pi by just typing pi. I'm already on the correct equation. If I hit pi and then hit enter, it'll go to that location. And it is 2 pi. So 6.283. G of 0. So I'm still on the correct equation. I'm going to hit 0. G of 0 is 0. Now, since we're using the calculator, I'm not going to write 2 pi, even though I could tell that was the answer. So I'm going to have 6.283 divided by pi, which should be 2. I need to find out when my derivative is equal to that. How? Oh, son of a gun. Guys, they yell at me. How do we do that on the calculator? I mean, I know how, I just, you guys have to figure out, know how to.
Are we assuming that, 6.283 is just too high?
Nope. No, since we're using the calculator, we'll go by the decimal.
Okay.
How do I figure out when the red equation is equal to 6.283 divided by pi?
Trace it at Q.
It's not a bad thought, but the trace feature only works on the x value part. You can't trace it for the y value, which would be super handy, but they don't let you do, it doesn't let you do that. Oh, was it a similar answer type thing?
Yeah.
So there's probably multiple ways to do this. The way I probably would do this is I would graph the derivative. Oop, I want to shut off the original function. I would graph the derivative, and then I would also graph 6.283 divided by pi. And it's just gonna graph a flat line. But if I do that, then I can find where the derivative is equal to that by doing the intersection. There's probably multiple ways to find this answer. This is the most straightforward one. So I'm gonna go to the intersection feature under calc. And it looks like there's two intersections. First curve, red. Second curve, black. Guess. I'm gonna go to that first intersection spot, which is probably pi thirds, but we'll find out. Nope, not pi thirds. 0.785. Sounds good. C equals 0.785, and one more answer. So I'm gonna go back and do the intersection thing again, and I'm just gonna follow the on-screen directions. First curve, well, actually, I can't tell where it's flashing on red.
Wait, Mr. McLeod?
Go for it.
Why is 0.75 just a C value and not like the derivative, like f prime of C? Because if we're finding it at the slope line. Does that make sense?
So the C is like an x value,
Yeah,
and our goal is to just find the x values where the average slope, which is our black line, is equal to the instant slope, which is the red line.
okay.
So the answer you're giving is x values only, even though they call them c values.
Okay.
I think that's what you were trying to ask?
Yeah.
2.356. And that's what we were trying to find from the beginning anyway. Now, offhand, I get the impression you guys are much worse off on your calculators than where I was assuming or expecting you to be at this point. Have we not done enough calculator things, or is it you guys just don't really use them like in homework when it says to use them?
We don't like do enough calculations.
In here?
Yeah,
Okay.
the first 5 units we did like 0.
Yeah, it's fair enough. Okay, I will try to purposely kind of try to put more in if I can. Because obviously by May, you're supposed to be able to use the calculator for all the different things you need to. Which, for the most part, this was a lot of it. This is the main things you do on the calculator is how to find answers. So it involves functions, derivatives, and then finding when it's equal to certain things. And basically knowing how to use the trace button, how to use the different features. Okay, well, I wanted to give you more time than that, but it didn't matter to me. It's, like I said, I was okay with just working on whatever you would like. So, I believe I have the homework for 5.1 in Schoology already. I put it tentatively, I think I put it on the 30th or something, maybe the 31st. The test is definitely not on the 30th anymore, most likely, because we pushed to that other test a day later. So, tentatively, plan for January 31st. I'll try to update the calendar if I have time. But I think that's when I put it due in the Schoology.